Lesson 3.4 Interpreting Graphs. So a couple key words to use when you are describing or interpreting graphs. One is a transformation. A transformation is a change in the size or position of an object. So it can grow or shrink or just slide, rotate, all those good things that we'll describe in a moment. Translation. This is more particular, whereas transformation may be a general term. Translation is a more specific description. A transformation that slides a figure. Each point moves the same distance in the same direction. So you're moving a shape to the right, to the left, up and down. The shape stays intact. It's just slid along the coordinate grid. A reflection. A transformation involving flipping a figure over a line, like you would a mirror. So it would flip, but when you do that, it also becomes a mirrored image, so the shape is not exactly looking the same as it did before. A maximum. When you look at a graph, what is its highest point? Especially when it comes to parabolas and things like that. A minimum. The lowest point on a graph. So a max and a min. The zero of a function. A value of the independent variable that makes the dependent variable zero. So again, when you're asking for the zero of a function, the value of the independent variable that makes the dependent variable zero. So when is the y value zero? Okay, and we'll look at that when it comes to the graphs. In other words, what is the x-intercept of a graph? Alright, so here is a graph. You have a function and its graph. So based upon the picture, what is the max and the min of this function? Now max would be the highest point. So this would be its maximum right there. Let me clarify that right there. So what is the maximum? The maximum is found at -1, but the actual maximum value is 3. Now the line keeps going down to infinity in both directions, so it will never have a true minimum. So max is 3, min is none. Estimate the zeros. Well, zeros are x-intercepts. So where does our graph cross the x-axis? And that would be right there and right there. So what are the x values at those coordinates? Well, that would be -4 and 2. So the zeros occur when x is at -4 and at 2. State the intervals where the function is increasing and decreasing. So if you look at the picture, and we're going to go left to right. So as you go left to right, the function is increasing from, and I'm going to say -infinity, because it goes on forever, to -1. So it's increasing as you go this way, but then at -1 it stops right there, and then now it starts to go down. So it decreases. So increasing is from -infinity to -1, and decreasing is from -1 to +infinity. And that would describe the increases and decreases for that graph. Next one, we have a parabola given again, right here, or not a parabola. This one, if you notice, the cube would be cubic. Here's the graph of the cubic function, and let's talk about max and mins here. Now notice that it goes down forever, so it would not have a minimum, and up again here it goes up forever, so it would not have a maximum. But I want to give you a new word, and that is a relative max. I do this here. and a relative min. Now, a relative maximum and a relative minimum. So even though it goes on forever, up and down, we can say that right here there is a relative maximum, and that would be at, let's see, -3, +3. So a relative max at 3, that's what the y value would be, and a relative min down here, I'm going to approximate that, we'll say at about -6. That was not on our first page, but vocabulary, but this is something you'd use for Algebra 2 trig. There is no max or min, but there's a relative max and a relative min, meaning approximately at those locations. And then when you state it that way, you know that it actually isn't the exact max or min, but you do have those little humps there and valleys. Let's estimate the zeros. Well, right there, and right there. Let's approximate those. So let's go to integers. So it looks like when x is a -4, again this is approximate, a -2, and about a 1. That's where the x values are. It's not quite right, but it is approximate, and they say we can estimate. Alright, so let's look at the intervals. We have intervals. It is going to increase, again, as we go left to right, from -infinity, this is an arrow, from -infinity up to -3, and then it starts to go down. But so then I'll say down here it decreases from -3 to, looks like 0. Again, we'll approximate this. It's decreasing, and then again it increases from 0 to +infinity. Okay, so we're increasing from here to here, then we're decreasing from here to here, and then we're increasing again from here and on. So 3 different places you have an increasing graph. Describe the change in the graph compared to f of x squared. So here is what we would call our parent function. Now we're going to talk about what it looks like to move things around and how equations can affect the way it looks. X squared. Now I'm going to go to this equation, or my calculator, and type in y equals. So if I go to, I'll clear this, if I go to y equals, I put in x squared and I graph it. Now there's my regular parabola. Now let's see what happens here when I type in, I'll go down to my next equation, I'm going to put in y equals x squared minus 3. Let's see what that graph looks like. Now look what happens. My original graph had a minimum at 0, then it went back up again. It shifted down 3 units. Down 3 units. So if I look at my table, it would show that same change. So it's, the minimum would be at 0, -3, that's the coordinate of the minimum, right there. So the minimum would be now -3 instead of 0. So it was at the origin, the minimum was at the origin, and x squared minus 3 shifted it down. That's a translation. Next one, let's try that one. Y equals, and let's go down to the third equation, and it's going to be parentheses x minus 3 parentheses squared. Let's graph that. Now look what happened. It shifted it to the right. So it was at the minimum was at the origin, and now the minimum is at 3 units to the right. So if I look at this, my graph, my coordinates would reflect that. So what happened? Describe the change. So the first one shifted the parabola down 3 units. So I'm going to type in here actually. So I'm going to say shifted down 3 units. That's this one. And the next one shifted right 3 units. Now I want to make an observation here for us that when you subtract from the function that you started with, it's going to shift it up and down. So negative 3 went down. If I had went plus 3, it would have went up. However, if you're putting in values in the parentheses affecting the x, whereas the other one affected the x squared, this one will move it right and left. However, it does the opposite of what is in the function. It said minus 3, so we would naturally think, well, if it's going to affect x and it says minus 3, we're going to go left. But the uniqueness of functions in this situation is that it will actually shift it to the right. Again, outside the parentheses, outside of affecting the x itself, it does exactly as it should, minus 3 down. But in the parentheses, it's going to shift left and right, and it will do the opposite. And we'll see a lot more of that as we practice. Alright, this ends lesson 3-4.